All right, this is the third of 3 videos on problems that I didn't get to in class. The second one was especially long. The first one didn't go too badly, but the second one was very long. This one could, in fact, be a little bit long as well, but let's get it going. So if you've watched the other 2, you already know by now that I blah my way through this, and I want to find what is it that we're looking for, and what was his uphill rate. Okay, so I'm going to say R is uphill rate. And then I'm going to start looking to see if I have a rate that was faster or slower. So Devontre rode his bike uphill 5 miles and then back downhill. The rate at which Devontre traveled downhill was 20 miles an hour faster than his rate going uphill. So we do know that R plus 20 is his downhill rate. Then it says if it took him 20 minutes longer to ride. So we are comparing times again. That's a big deal. It kind of tells us where we need to start. And we want to start with T is equal to D over R. This is why I mentioned in class, and if you weren't there, you didn't get to hear that part, but when I mentioned in class, all of the problems I've come across in Newton are of this type so far. It might change. I can't tell you for sure that it's always going to be that way. However, the ones that I've come across are of this type. You're going to use time is equal to distance over rate. Now, do you always do that? No. You have to read and see what it's asking here. Because it says it took him 20 minutes longer, we're comparing times. That's how I knew that we needed that version. We may need distance versions later. It's a crapshoot. So here we go. Let's go ahead and build what the equation should look like. So he rode his bike uphill, then he rode his bike downhill. All right, so our time uphill took 20 minutes longer than downhill. This is a difficult concept for people to grab, and to be quite fair on it, I struggle through this myself, and I have to put it in very simple terms so that I can understand what I'm doing. When I put an equal sign here, I'm telling myself that both sides must be the same. So if I put the downhill time here, time downhill, then I have to find out where does the 20 minutes fit, and then we're going to have to change it on top of that. So bear with me on that. But we're going to get the 20 minutes in there first, and then we'll deal with the issue. So I spent longer uphill. That means in order to make them equal, I need more time downhill. So I have to add my 20 minutes to the downhill side. That's the way I tend to think about it. It's kind of like if you have $5 and I have $5 more than you, who needs to be added to in order to make it equal? That's how I view the problem. There are at least 3 different ways to set this problem up. So if you don't like this method, let me know, and I will show you a different method that might make more sense to you. So this is what our equation is going to look like, and now I said we have to fix it. And you're like, why do we have to fix it? What's there to fix? Let's just do the problem and be done. We got a problem. You see, the rates are given in miles per hour. That's the problem. But our time difference is given in minutes. The two do not agree. So I either need to change the rates to miles per minute, or I need to change the minutes to hours. And it's going to be a lot easier to change the minutes to hours. So my time uphill, and I'm just going to say time uphill, TU, is equal to my time downhill, TD, plus 1/3 of an hour. 20 minutes is 1/3 of 1 hour. So now we have our equation. So our time uphill, remember, just like in the previous couple of versions here, I just need my distance over my rate. So I rode 5 miles uphill. So 5 over my rate, which is R. and then that equals my time downhill, which is 5 miles up and then back down. So 5 miles downhill, with my rate changed to r plus 20, and I have to add 1/3 of an hour to my downhill side. So I just go ahead and solve this out. Now, this is going to start getting a little hairy, but I have to multiply by every single denominator. So it's 3r and r plus 20. All of that gets distributed through. That's going to give me, the r's cancel. I have 5 times 3, and then the r plus 20. So it's 5 times 3 times r plus 20. That's the first term. Equals. My r plus 20's cancel, leaving me with 5 times 3r. Well, I'll clean this up on the next step, but I just want to get it down first. And then my 3's cancel here, leaving me with 1 times r plus 20. Now let's clean that up a little bit. This piece here is going to give me 15, and I'm going to distribute that across. This here is just going to give me 15r. This is just going to give me r, and I distribute that in. So when I do that, my next step is going to be down here. I get 15r plus 300 is equal to 15r plus r squared plus 20r. Now, I can't, unfortunately, well, that would be nice, wouldn't it? I can't get rid of my r squared, so I'm going to move everything over. But the fun part of this is, even though I can't move r squared, I can notice that I have a 15r on each side, so that when I subtract them, they're going to end up eliminating one another. So those are going to go to 0. So I just have to worry about moving over the 300. That's going to give me 0 is equal to r plus r squared plus 20r minus 300. And now I need two numbers that multiply to 300 that subtract to 20. That's not too bad, but it might take you a while to find it. I just happen to, I almost always start in dividing by 10 if there's a 0 at the end. That would give me 10 and 30. And if you notice, 30 minus 10 is 20. So it just turns out that I got lucky in my first guess. So that means that my 30 is positive, so r plus 30, because this one, the larger of the two takes the positive. Their signs are different, so this is going to be r minus 10, and that equals 0. Okay, we just solve from there. It gives me r plus 30 is equal to 0, or r minus 10 is equal to 0, which means that r is equal to negative 30, or r is equal to 10. Again, we have to decide which one of these we will accept. So we look up here and we say, okay, well, what is r? Well, r is a rate. It's how fast he's riding his bike uphill. Well, negative 30 doesn't make any sense there, so we kill it. It's not an option. So our only other solution is r is equal to 10. So he must have been riding his bike 10 miles an hour uphill. And that's it. You'll notice that the sign of the 30 is opposite of what you need for r plus 20. That tends to happen a lot in these cases. So if you need to know both, then one is 1, the other is just flip the sign and you're done. And the reason it turns out this way is because of the method of solution. That's the reason it ends up turning out this way. All right, I hope this helps. I know that word problems can be very difficult. Spend some time on them, because in real life, let's face it, nobody has an algebra problem for you to do. You actually have to find things to get to the algebra to then do the algebra. Sometimes it sucks. Sometimes it sucks even harder. So, hope this helps. If you have any questions, let me know. Thanks.